All right, so we're looking here at our review of the Unit 2, and it starts off with do not use calculator. Okay, so uh, I know immediately then if I'm not using the calculator, the only way I can do my trig functions is I need to know some special right angles. Sorry, special angles coming from the right triangles. So if I look in the first quadrant, right, I have 30 degrees. I have 45 degrees. I have 60 degrees. Okay, and also 90 degrees. And then I can also put in my 0 or 360. Okay, and then coming around with that as well, that's 2 pi, 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians, and then pi over 2 radians. Okay, so pretty easy. We know our degrees pretty well. Just remember the fraction denominators are 2, 3, 4, and 6. You almost want to put a 5 there, but be careful. So it's 2, 3, 4, and 6. And it's the smaller fraction first, or you can kind of think of the larger value last first. Okay, larger value denominator. Okay. So we have that. And then I also know that at this point on the coordinate plane, this we said we would call this 2, 0 because we're using our value of 2. We're going to use our radius as 2. So when I come up here, right, I have to try and remember, well, what are my other things? Well, I know that 2 is the square root of 4. So this is the square root of 3, then the square root of 2, square root of 1, and then 0. Okay, and then the y value is just the opposite, right? It'd be square root of 1, square root of 2, square root of 3, and then 2. So now I have the basics of what I need to answer questions. So this first one is cosine of 45. So I come over, 45 is located at square root of 2, square root of 2 when I come out 2 units. So that means that cosine, which is the ratio of x over r, will be the square root of 2 over 2. And 45 is in the first quadrant, so it's positive. So square root of 2 over 2. Over here we have cosecant of 135. Well, 135 is not in the first quadrant. I know that if 180 degrees is over here, then 135 should be in the second quadrant. Cosecant in the second quadrant is positive, so I know my answer is going to be positive. 135, well, I need to, how far away is it from 180, right? So we do 180 minus 135, and we find out it's 45 degrees as well. So cosecant is the ratio of r over y. So that will be 2 over, right, r is 2 over the square root of 2. Okay, but we won't leave it like that because we don't like to leave our denominators in the bottom. So I multiply both by square root of 2. Simplifies out to simply be the square root of 2. Okay. All right, 2 pi over 3. Well, 2 pi over 3, also not in the first quadrant. If I do a quick sketch, right, if the pi over 3 is here, then the second one is over in the second quadrant. Sign in this quadrant is also positive. Okay, pi over 3, 2 pi over 3 is going to relate to pi over 3 over here, which is also our 60 degrees. And that was the y value is square root of 3. So that's going to be square root of 3 over 2. And that's it. Okay. Tangent of negative pi over 2. Now, this is one of our specials. It has not our quadrantals. Okay, because negative pi over 2 means we're coming this direction to negative pi over 2. Okay, so at that point, we know that x is 0, and our y value would be negative 2, because we said we were always going to come out, our radius would be 2. Okay, so we came down to, so tangent is tangent is y over x. So negative 2 over 0, well, you can't divide by 0, so that is simply undefined. All right, secant of 5 pi over 6. Again, not in that quadrant, but it's going to be relative or the referenced by pi over 6. Secant is the ratio of r over x. Secant, okay, so that would be the square root of 3 over 2. Okay. But we have to check what quadrant is 5 pi over 6 in. Well, it's less than 1, but pi over 6 is here, so 5 pi over 6 is over here in the second quadrant, and where secant is negative. Okay. Similarly, sine of 3 pi over 4. Pi over 4 is 45 degrees, or square root of 2 over 2. Square root of 2, square root of 2 is its location. So y, sine being y over r, means that would be square root of 2 over 2. And then we look for where is 3 pi over 4 located. Well, if we count around, 1 pi, 2 pi, 3 pi is going to be here in the second quadrant where sine is positive. So my answer is square root of 2 over 2. Okay, tangent of 60 degrees. Seems pretty straightforward. That's where x is square root of 1. And y is square root of 3. So tangent being y over x would be the square root of 3 over the square root of 1, which we simplify to simply the square root of 3. Okay, secant of negative pi over 3. Well, it's referencing pi over 3, so I'm going to use those x, y, and r values. Okay, so secant is x over r, square root of, which will be the square root of 1 over 2, or simply 1/2. Okay, and then I look, secant of negative pi over 3 means I would be going pi over 3 this direction, so I'm in the fourth quadrant. Secant in the fourth quadrant is positive, so 1/2. Okay, cotangent of 30 degrees. Cotangent is x over y. Oh, that doesn't look much like an x. There we go, x over y. And so that's going to be square root of 3 over square root of 1, which is square root of 3. And it's in the first quadrant, so it's just square root of 3. Okay, finally, cosecant of pi. All right, now pi is one of our quadrantals, so we're going to come over here and just deal with pi directly. It is located at negative 2, 0. Okay, on our, where r is 2. So cosecant is r over y. So r is 2, y is 0. Can't divide by the 0, so it's undefined. Okay, let's look at some more samples. All right, find values of theta that satisfy each statement for 0 to 360 degrees and 0 to 2 pi. List your results in degrees and radians. All right, so this was where we said, okay, you need to isolate your sine or your trig function, in this case sine theta. So we're going to subtract this 1, and we'll have 2 sine theta equals negative 1. Then we divide by 2. So sine of theta will be negative 1/2. Okay, so we've got two things going on here. We've got the negative and we've got the 1/2. Well, the reference angle for where sine is 1/2 is when we are at 30 degrees or pi over 6. Okay, so with that being the case, we know that it's negative, so we look at sine is negative in the third and fourth quadrant. So we need the to know what that is. So if we're here, right, we're going 30 degrees or pi over 6 in this direction, so we're adding it. So we would say theta could be 180 plus 30 degrees, which is 210. Okay, or we can say theta is pi plus pi over 6, which is 7 pi over 6. Okay, if we're coming in this direction, we're going to say 360 minus 30, which is 330 degrees. And then we also have 2 pi minus pi over 6, which gives us 11 pi over 6. So because we're doing them both, all 4 of these would be our answer. All right, let's look at number 12 here. 3 secant squared theta minus 4. So again, we're going to isolate our trig function. We're going to add the 4. So we have 3 secant squared theta equals 4. Then we divide by the 3. So secant squared theta equals 4/3. Okay, so we take the square root. So we have secant theta. We take the square root of 4/3, and we're going to have 2 over the square root of 3, and it's going to be plus or minus. Okay, now remember secant is r over x as a ratio, so that means r equals 2, x equals the square root of 3. It says plus or minus, so that kind of gives us a variety of directions. And so if we look back at our first little drawing we did, x is the square root of 3 at 30 degrees. Okay, so I know my reference angle is going to be 30 degrees, which is also pi over 6. Very much the same as we saw in the previous one. Okay, so if that's my reference angle, the next thing is it could be positive or negative. So that means it's all the quadrants are going to be represented. So 30 and pi over 6 are going to be answers. Okay, as well as when we have 180 plus 30, or let's start with 180 minus 30, 180 plus 30, and 360 minus 30. Sorry about that. And then we can also use our radians, which pi over 6, and then pi minus pi over 6, which is 5 pi over 6. Okay, and then pi plus pi over 6, which is 7 pi over 6. And then finally 2 pi minus pi over 6, which is 11 pi over 6. Okay, so all of those are possible ways that we could represent theta in this equation. Okay, I'm going to go ahead and stop this video there, and we'll pick up on the next video with the next few.